This lesson introduces what we call rational exponents. In this context, rational is just another word for a fraction. So we've looked at whole number exponents, x to the first, x to the second, and so on. And we've also extended that to include the zero exponent and negative exponents. Now we're going to explore what happens when your exponent is a fraction. Let's start with perhaps the easiest example, a unit fraction. That means where the numerator is 1. And among the unit fractions, the first to consider would be x to the power of 1/2. So you might not know how to handle something like that, but here's how we are going to get an answer for that. Well, we know from our exponent properties that when you multiply with the same base, you add the exponents. 1/2 plus 1/2 is 1 whole. So if you think about what that's saying that x to the 1/2 should multiply by itself to give you x to the first, or x. So essentially, x to the 1/2 is the same thing as the square root of x. Okay, and then we could also do an example with numbers. So imagine you had 16 to the power of 1/2 times 16 to the power of 1/2. Well, that should be 16 to the power of 1, which is 16. So whatever 16 to the power of 1/2 is, it has to multiply by itself to give 16, so it's 4. So 16 to the 1/2 is the same as the square root of 16, or 4. Okay, so in general, let's see, we could say, oh, maybe I didn't write it here. All right, let's go ahead and move to the next screen where we consider a unit fraction where the denominator is now 3. So again, we can use our exponent properties. We know that if we multiply the same base, we can just add the exponents. 1/3 plus 1/3 plus 1/3 is 1 whole. So here's an example with numbers. Let's say 27 to the 1/3 times 27 to the 1/3 times 27 to the 1/3. Well, that should be 27 to the, well, 1/3 plus 1/3 plus 1/3 is 1 whole, which is the same as 27. So even though you might think 27 to the 1/3 is 9, 9 times 9 times 9 is way bigger than 27. It turns out the only number that's going to work here is 3 times 3 times 3. So 27 to the 1/3 is the same as the cube root of 27, which is 3. Okay, so in general, we can say it like this. All right, and let's move that over so you can see that. That if your exponent is 1 over n, you're taking the nth root of the number. And this applies even to the following. Say I told you that I wanted you to find 1024 to the 1/10. Well, that would be the same as the 10th root, not the square root, but the 10th root of 1024. You may not know this off the top of your head, but 2 to the 10th is 1024. So the 10th root of 1024 is 2. All right, so that's what you do when you have an exponent where the numerator is 1. You just take the denominator, and that's the root you look for. Okay, what if the numerator isn't 1? So for example, suppose you have x to the 3/5. Well, I'm going to break that apart and say that's the same as x to the 1/5 times 3, because 3 times 1/5 is 3/5. And then using the power of a property, the power of a power property, I can write that this way instead, because the power of a power property says you would just multiply those two exponents. And we know from the previous screen that x to the 1/5 is the fifth root of x, and then that needs to be cubed. So here's an example with numbers. Suppose you had, let's say, 64 to the 2/3. Well, that's going to be 64 to the 1/3 squared, which is the cube root of 64 squared. The cube root of 64 is 4 because 4 times 4 times 4 is 64, and 4 squared is 16. Okay, so let's put that in symbols for you. Somewhere down here at the bottom of the page. I thought it was. Maybe it's on the next screen. Oh, yeah. So in general, if you have x to the m over n, well, that's the same as x to the 1 over n to the m, or the nth root of x raised to the m power. And maybe I have that in general down here. Okay, yeah, here it is. Now, notice that I wrote it in two ways because it's allowed for you to take the nth root first and then raise that answer to the power of m, which is the way I generally do it. But it's also okay to raise x to the power of m first and then take the nth root. I would just rather make the number smaller by taking its root before I make it bigger by taking a power of it. Okay, so that's how fractional exponents work. The denominator tells you what root you're looking for, and the numerator tells you what power to raise that to. Alright, so for your homework, I want you to try these without a calculator. Your answers should be whole numbers for all four of them. You can check your work with a calculator, and we will go over it tomorrow.